So we have learned about dimensions, and we're going to apply this dimension now in a technique that we can call as dimensional analysis. But before we get deeper into dimensional analysis, I believe you need to know the idea behind dimensional analysis. To do that, we need to understand this statement over here. Okay, so you mentioned that a physically valid or meaningful equation should be. Okay, so if you want a equation to be valid, you have to fulfill the following criteria. So there are three criteria here. I'll explain them in detail, but for now I'm going to just read through here to let everyone have a rough idea first. Okay, so any equation must have the same dimension on its left and right side. So if you want a valid equation, the left hand side and the right hand side of the equation should have the same dimension. Okay. The next one is only terms or quantities having the same dimension can be added or may be added or subtracted. So if you want to add A and B, if you want to add A and B together, A and B should have the same dimension. The third one, terms and quantities having different dimensions can only be multiplied or divided. So it's sort of continue from the second statement actually. So if A and B have different dimensions, you cannot add them together, you can only multiply or divide them. Okay, so I'll go through them in greater depth now, but I'm not going to do it really formally. I'm going to do it a bit casually, sort of like trying to talk about logic actually. So let's get into it. Any equations must have the same dimensions on its left and right side. Let's go straight into an example. Well, now I have 3 apples plus 4 apples, and the answer is 7 apples. So if the right hand side of the equation is talking about number of apples, the left hand side of the equation should be talking about number of apples. Well, if I say the 3 apples is B, the 4 apples is C, then the 7 apples here will be A. So if this equation is said to be valid or meaningful, what I need to achieve is that the dimension of A should be the same as the dimension of the right hand side. So the dimension of right hand side, it's called dimension of B plus C. So the dimension of B plus C should be the same as the dimension of A. And in that case, this equation is said to be a valid equation or the meaningful equation. So that's the idea behind the first sentence. Now, if we change another example, and now 3 apples plus 4 apples equals to the temperature of coffee. Well, it sounds weird, right? It's already not logic anymore. Okay, why? Because if the temperature of the coffee is now D, then we know that the dimension of D is temperature. Whereas the dimension of B plus C here is actually talking about the number of apples. So, well, temperature and apples, how do you equate them to each other? They don't have the same dimension. So in this case, you see that D is equals to B plus C. This equation is not meaningful, or it's not a valid equation. Okay, so that's the idea behind the first rule. Very simple, right? Let's go to the next one. Only terms or quantities having the same dimension may be added or subtracted. So if we use back the same example, but we focus only on the right hand side of the equation. Now 3 apples plus 4 apples, if you look into it, the 3 apples is measuring number of apples. The 4 apples there is also measuring number of apples. So if B and C, B is 3 apples, C is the 4 apples, if you want to add them up together, the dimension of B and the dimension of C should be equal. Okay, so in this case, since they are equal, we can say that B can be added to C. So this is a valid situation. But if today, let's say I want to add 4 apples with 2 apple pie. Now there are 2 different things. One is number of apples, one is number of apple pies. So in that case, A apple plus P pie. what should you call it? The dimension of P and the dimension of A is definitely not the same thing. One is apple pie, one is apple. So they are different things. So if you want to add them up together, it won't really make sense. It's an invalid equation. If you add up apples and apple pies, what should you get? Apple, apple pie, pie apple. Well, it doesn't make sense, okay? So in that case, this is not a valid situation. Okay, that's the second criteria you need to achieve. You need to have the same dimension if you want to add them up together. Okay, now the third one. The third one, terms or quantities having this different dimension can only be multiplied, well, spelling mistake, or divided. Multiplied or divided. Okay, so in this case, number of apples and number of apple pies, if you really want to make it a valid equation, it can only be a multiplication, not an addition or a subtraction. Okay, multiplication or division is allowed. So let's try to manipulate the situation a little bit. Now, if we say these 4 apples is the number of apples needed to make one apple pie. So you need 4 apples to form one apple pie. And now you can change this to number of apples needed for one apple pie. Now the situation here, we can change it to a multiplication. We can change it to a multiplication. So if the number of apples needed for one apple pie is 4 apples, if you need 4 apples for one apple pie, and you're making 2 apple pies, you need 8 apples. Okay, it's still a very logic situation now, right? If we put it into a multiplication. So 8 apples here is the total number of apples needed for 2 apple pies. So now in this situation, even though P, the number of apple pies, and A, the number of apples needed for one apple pie, even though they don't have the same dimension, we can still multiply them together. There's no problem with it. Okay, so that's the idea behind the third rule, the third criteria over here. And if we are able to follow the third criteria, does that mean that we break the first or second criteria? Let's try to investigate it. Okay, so T here represents total number of apples. T here represents total number of apples. P represents number of apple pie. A here represents number of apples needed for one apple pie. So now P times A will be equals to T. So let's try to see what are the things that they are measuring. For A, you are measuring apples needed per apple pie. So if you talk about the unit or you talk about the dimensions, it's the apples per apple pie. Okay, just a rough idea because this is not exactly a physics equation. I'm just giving you a rough idea of things. So P here should be number of apple pies. And T here we know it's number of apples. So are we able to follow the first criteria? Let's check. Apple for P is up. Apple pie for P is up there. Apple pie for A is down there. So what can we do? We can cross them out and we can see the left hand side and the right hand side of the equation have the same dimension, which is the number of apples. In this case, you are able to follow the third criteria, but at the same time being able to follow the first criteria. The second criteria is not really relevant here because we are not adding anything. So if you see here, we didn't violate or we didn't break any of the criteria over here. So in this case, T equals to P times A is a valid or meaningful equation. Okay, so these are the 3 criteria that we usually need to check when we want to see whether an equation is valid or not. Okay, now in later videos, we'll really apply the idea of dimensional analysis in a few examples.